Good morning, everybody. I'm John Lanning. I'm a senior consultant with Comp Management Risk Services. That's a big, long title that basically says I'm a safety guy. I work with companies basically all over the state of Ohio in the manufacturing, service, retail, transportation industries, construction, to implement OSHA compliance programs, written programs, as well as training to control the frequency and severity of accidents in the workplace. I do a lot of, I'm also a member of a team that it's a national team. We basically do the same thing with large clients such as Home Depot, Lowe's, Pepsi-Cola, Saks Fifth Avenue, and companies like that. You would think that you know, if you have a 3-man landscape company over here, that or a 5-man painting company, that maybe these folks don't really have all their little duckies in a row and this and that. But you'd think that a big corporation that's been around for many, many, many years, that they'd have all their T's crossed and all their I's dotted, and they don't. You know, there are many, many companies out there, both large and small. You know, they got machine guarding issues. A lot of people say, well, you know, I got to buy this $2 million piece of equipment that was made in Shanghai, and I put it in my factory. Next thing I know, OSHA's in here giving me a fine. Well, what's that all about? That machine, you know, was built to the regulations, whether it be in China, Japan, Korea, or whatever. When that machine is brought into the U.S., it has to be made acceptable to OSHA standards. Machine guarding is probably one of the most cited regulations that are out there, because the reason is most of the injuries occur, you know, because of machine guarding, either because somebody puts their hand around the guard or the guard is not there at all. So one of the things we're going to discuss today is the different kinds and types of guarding and what we can do to ensure that nobody gets injured. Topics to be covered: identify dangerous parts of the machinery, identify hazards and actions and motions of machinery, and methods of safeguarding. As a rule of thumb, any part or function or process that may cause injury must be safeguarded. I mean, these people out there now are getting to the point that the automotive industry is even being scrutinized today because of the serpentine belts and things like that, because you have mechanics out there that are working in these shops, they're putting their hands in there. And so now OSHA's even taking this thing one step further. So, well, wait a minute. We want to make sure that an employee, regardless of what kind of a position they may have or occupation, that whatever there is that they're working on needs to be safeguarded. You think, wow, that's really going to a big extent. Where dangerous mechanical hazards occur is point of operation, nip points, pinch points, power transmission, and other moving parts. The machine safeguarding is an application of safety, engineering, and work practices and administrative controls to prevent the injury of employees who operate the machinery. It's not only just the employees or the person operating the machine, it's everyone around them. We want to try to recognize the hazards, analyze the workplace, develop and implement a systematic safeguarding program, and ensure that the safeguarding and reinforcement programs by training. Anytime that an employer provides any kind of training to the employee, make sure that it's documented. Because there's been too many cases, and will probably continue to be cases, that someone will become injured, and the injured employee will say, well, nobody told me not to stick my hand in a fan. Well, if you told somebody not to stick their hand in a fan, make sure it had a guard on it, and make sure you documented that. Because if somebody does get seriously injured, they're going to look for that information as to, well, was this person properly trained or not? A wide variety of mechanical motions and actions may be present and a hazard to the workers. There's rotating motion, spinning, reciprocating motion, which is basically back and forth, traverse motion, which is basically one way. One way is probably a good example is conveyor belts. You know, there are a lot of people get injured on conveyors every year. There's a person over down in Columbus, Ohio. It's been about a couple years ago. Conveyor was running, and he decided he was going to clean up under the conveyor while it was running. So he was under there, you know, a couple foot space. He was under there, and he happened to notice a piece of debris up here. And all of a sudden, you know, he decided he was going to try to remove that. And yes, he did get seriously injured. Problem with that scenario is the fact that not only the fact he was seriously injured, but the employer was highly fined for that, because the bottom of the conveyor was not guarded. You know, they should have had a pan or something under there to keep that from happening. Rotating motion can be dangerous. Even smooth, slow rotating shafts can grip hair, clothing, through minor force of the hands in a dangerous position. You know, that's the reason you probably, if you're working in manufacturing, probably somewhere along the line, depending upon the kind of machine that you're operating on, it's got a rotating motion, whether it be a shaft or whatever, they'll tell you not to wear long, loose sleeves. They'll tell you not to wear a necktie. They'll tell you, you know, if you do have long hair, you know, make sure it's pulled back, because it gets pretty ugly. You get your hair caught in one of these rotating shafts, or if you get your shirt sleeved or something like that, it gets really ugly really fast. Most of these injuries, whereas, you know, a piece of equipment needs to be safeguarded, and it's not, then most of these injuries are very, very serious. We're not talking about, you know, a nick or a small cut. We're talking about usually, you know, these kind of injuries are pretty severe. Rotating parts, nip points run the opposite direction. Rotating parts, you know, there again, you know, as you know, chains and sprockets, you know, which may be hooked to a conveyor system, something like that. Nip points between rotating and fixed parts. Nip points can occur between rotating and fixed parts, which create a shearing, crushing, and a braiding action. Examples would include spoked hand wheels. You know, those get pretty ugly when they're not guarded, because if this thing right here is spinning around and around and around, and you happen to you put your hand in there for whatever reason, I think you can, you know, put it in your own mind how ugly that can get real quick. Abrasive wheels, same thing. Anybody got any abrasive wheels in their shop? Probably everybody. If it's not manufacturing, you know, even construction industry, all kinds of industry has probably got one of these in the shop somewhere. Reciprocating motions may be added because during the back and forth and up and down motion, the worker may be stuck or caught. There's a lot of movable tables that are out there that unless you are in a position that you're supposed to be, when this table moves, you're in trouble. So therefore, you know, what we want to do is make sure this person's out here somewhere. But there's a lot of companies out there that, because of room, you know, they buy a new piece of equipment, it's shoved into the corner over here, shoved into the corner over there, and you know, we're going to get that fixed, but right now we have to make production. And so therefore, you know, somebody's put into a compromising situation that somebody ends up getting hurt. Traverse motion, movement in a straight continuous line. There again, you know, it basically conveyors and things like that, or belts. You know, on a piece of equipment you may have, say, an electric motor, you know, driving a large fan. Same thing. You make sure that belt is guarded. And everybody, you know, says, well, you know, that it's okay, you know, that we make sure that we tell our employees, you know, not to go near this or not to go near that, and we got to be careful around here. And the employee that's out there every day, he or she may know that. But all of a sudden, you know, we have someone out of the front office, you know, it's got a nice necktie on, looks real sharp. They have a salesman into your facility. You know, they want to try to sell you something. They'll say, well, come on over here, Bob. We're going to show you what we need to have done over here. And what happens? You know, these people that are not out there on the floor every day, all the time, may or may not be aware of the fact. They may be aware of the fact, and because they're interested, you know, in buying this new piece of equipment or whatever, they're not thinking about the fact that whenever they bend over like this, you know, to show somebody that we need something over here, guess what happens to that tie they have on, or loose clothing, or a necklace. Cutting action may involve rotating, reciprocating parts. Probably one of the ones that we can really look at. Everybody's aware of the fact, you know, that we have you know, drill presses, mills, table saws, band saws, things like that. Unless these things are guarded properly, somebody gets hurt. And they're going to say, well, wait a minute, you know, we've had this drill press in our shop for the last 25 years. Nobody's ever been hurt. Have they been lucky? Maybe. Maybe they've been lucky. Shearing action involves applying power to a slide or a shaft. Anybody got shearing operations? Tell you what, they can get pretty ugly pretty quick. Especially, you know, that a lot of people, you know, they think of a shear, the first thing they think is the metal industry. You know, forming metal, cutting metal, sheet metal, things like that. This kind of shearing action is also used in the veneer business. Be aware of a veneer company? Got these big books of veneer that's about 50 millimeters thick, and they got to cut them to shape, or just different sizes. You know, another one, an example is in the paper industry. You'll have books of paper, you know, big blocks of paper, maybe 12, 14 feet long, that's going into a shear and coming down. And there are ways to prevent that, those injuries from happening too, that may be somewhat different than you would find in normal industry. But I guarantee that these kind of injuries right here are not pretty, you know, not pretty at all, because that machine at this point doesn't know what, you know, whether you're cutting paper, cutting veneer, or cutting fingers. Punching operations. Punching action is when a power is applied to a slide. Basically, you know that you can have this in two different ways. You know, you got a strip of metal coming down, you got a die, and basically what it's doing, it's punching out parts. They may be round, they may be square, they may be you know, shaped like a key, you know. But because of this die, you don't want to have your fingers in here, you know, whenever that piece of machinery is in operation. People have tried for years and years and years to try to beat this system, and there are ways you can beat it, you know, but these are the people also involved with very serious injuries. There again, bending actions, you know, you're basically, it's a forming die. You have the piece of metal goes into a die, you know, the ram comes down, it forms the part, you know, and then it's kicked out and goes down the line, and another piece of sheet metal is put in its place. A lot of times these are continuous feeds. You'll stamp, 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 and then you have to form a part, and it'll get down the line further to be cut into individual pieces. Especially in the automotive industry, these pieces can be very big, and some of these, you know, can be 20 to 40, 60 tons, and you don't want to be near it. There's a lot of older machinery that's out there. I know of at least one company that's still using forming dies and things like that on equipment that was made back in the 40s. They had the big flywheels on the sides of them. The machines were big and heavy and bulky, you know. And once that wheel starts spinning and that die comes down, I tell you what, there's very little going to stop it. Your fingers are not going to stop it. Methods of safeguarding. You have talked about the different kinds and types of injuries that may be out there, and different kinds of types of situations. But you know, there are many ways to safeguard the machinery. And the means and methods of preventing employee contact with a moving part. That's what a guard is. It's to keep you from putting your fingers where they're not supposed to be. You should first determine the machine hazard, then select a suitable guarding. You know, there are many, many, many companies out there that provide guarding for just about anything and everything that are out there. Rockford Corporation out of Rockford, Illinois. I'm not giving them a big name here, but tell you what, that company has just about any kind and every kind of guard known to man. You can go online, it's rockford.com, and you can see the kind of types of guarding that they have available. Anything from a mill and a drill to just about anything you can imagine. One thing that you can do, you can go online, get a catalog, see what they have and this and that, and then perhaps make it yourself, you know, to suit your kind of type of machine. Production requirements or limitations may also help determine the appropriate safeguarding method. This is a big one right here, because it's not so much anymore, but it used to be people used to run piece rate. Anybody here run piece rate in production? And what that does, you know, if you have a metal stamping operation or a forming operation or something like that, how do you get paid? You get paid a base rate plus bonus, right, for number of pieces that you make. So to keep things safe, what companies would do, they would actually, and we'll show a slide here in a little bit, they'll actually, you know, put in momentary switches. Whereas, you know, once the material is in the machine, you have to push down 2 palm buttons in order to get that machine to cycle. Well, man, if I have to do that, that's cutting into my production. I'm not going to make bonus. So people learn real quickly of how to beat that system. They take, you know, the older type of momentary switches, they'd push them down, put a toothpick in it, and break a toothpick off. Now one's down all the time. Now I can just operate with just one button. Next thing you know, they're putting their hand in there where it shouldn't be when the machine cycles. But that's that was one method that people tried to use to try to beat. And there again, they basically, you know, was limiting the number of production pieces they were getting. So therefore, I'll tell you what, it's very difficult for a person to be a man or a woman at their own trade. You know, if you're out there on a production floor, or you're out there, I don't care if you're a mechanic, I don't care if, you know, what kind of construction, what kind of business that you're in, you will definitely find ways to do a shortcut. Because you want to get done, you want to do the best job possible, but there again, you know, you want to get done with whatever task it is that you're doing, and you're going to find a way to do it. You know, I don't care if you're shoveling dirt, you're going to find a bigger shovel. That way I get this done quicker. As a general rule, power transmission apparatus is best protected by fixed guards. In other words, if it's there again, it's like a forming press or something like that. A fixed guard is usually the best way to protect that. You must always choose the most effective and practiced means available. Safeguarding strategies are grouped under these general classifications. First of all, we're going to eliminate the hazard. That's number one. If you eliminate the hazard, nobody can get hurt. Control the hazard. How are we going to control the hazard? You know, through fixed guards, interlocks, self-adjustable guards, different kinds of devices, controlling devices. You know, safe holding, safe operating. If it can't be done that way, then we go to safe practices and personal protection equipment. You go to PPE as a last resort. The main thing that you want to try to do is eliminate the hazard. If the hazard is no longer there, then we don't need any of the rest of this, right? Don't need the rest of it if, you know, as long as the hazard has been done away with. But what a lot of people or a lot of companies will do, you know, rather than trying to eliminate the hazard, well, first of all, you know, we'll just do this or we'll just do that. There again, you know, if a company tells you, you know, that they're going to control the hazard by a different type of guard, that if you really want to, and if you really feel as though you have to, remove a guard, reach around behind a guard, or whatever, you're going to get hurt. You know, those guards are there for a reason. Effective guards prevent contact. The safeguard must prevent hands and arms and other parts of the body or clothing from making contact with a dangerous part. That's most important. There again, you know, we're talking about shirt sleeves, we're talking about long hair, we're talking about, you know, things like that that can get entangled, you know, into a piece of equipment. I'll tell you what, it gets pretty ugly really quick when somebody has that happen. Secured and well constructed, a worker should not be able to easily remove or tamper with a safeguard. It should be your company's policy, written policy, that if indeed you remove a guard or modify a guard, that your disciplinary action should take place, and it should be very serious. We're not going to slap people's hands and say, well, you know, you reached around, you took that guard off for a reason. You know, because you worked first shift in a manufacturing environment, you removed this guard, or you modified this guard, or you readjusted this guard, and you worked first shift because that's what suited you. The thing of it is, you go home, and the person on second shift or third shift comes in, and maybe they're not really aware of what you did. You know, and next thing you know, somebody gets injured. So therefore, I would say, you know, the tampering with a guard, modifying a guard, removing a guard, you should be directly tied to disciplinary action up to and including discharge. Because whenever one of these accidents happen with a guard removed or where a guard is required, somebody loses fingers and limbs. That gets very ugly real quick. You know, there are also other kinds of guards that protect not only your fingers and your hands, but how about your eyes? You know, on pedestal grinders. Everybody got pedestal grinders? Sure you do. You know, you get debris coming off those into your eye because the guard was missing. Just a little piece of Lexan, that's not going to stop anything. Yeah, well, Lexan will. It'll help. Protect from falling objects, contain the hazard. The safeguards ensure that no object can fall into the moving parts. That's what happens when maintenance is working on a piece of equipment. I've been in manufacturing and construction sites, whereas somebody be working on a compressor, somebody be working on a piece of equipment, and they lay the tools up here. Screwdriver, hammer, wrench, whatever. What happens? Through vibration, it falls down in. Down that turning wheel, next thing you know, it's thrown 3 aisleways over and hit somebody. Should be able to create no new hazard. Now, I've seen this happen before too. People will put a guard on a piece of equipment or a piece of equipment in such a way that actually creates another hazard. Create no interference. The safeguard which impedes the worker from performing their job. You know, I shouldn't. I understand that the guard needs to be there, and it's very important. But now, because of this guard, now I have to go all over here to do my job. You know, I'm moving from here to here to here, and so therefore, you know, when we put the effective guards together, we, you know, create no interference, allow for safe lubrication. You know, maintenance people still got to get in here and do this stuff. You know, you've got a transmission belt, you know, such as a conveyor or something like that. They have bearings in there. They need to be lubricated on a regular basis. You know, you do not want a welded fixed guard on that because maintenance can't get in there to do that. So you want one that's adjustable. 4 types of machine guards: fixed, interlock, adjustable, self-adjusting. What's a self-adjusting guard? Fixed guards are usually a permanent part of the machine. There again, you know, you've got the air compressor. You know, you've got the flywheel that's going to operate a piece of machinery. You've got a fixed guard around there. There's no need for anybody to be in there. No reason for anybody to be in there at all. It's a permanent part of the machine, not dependent upon other moving parts. Constructed of sheet metal, screen, wire cloth, plastic. I would say Lexan, not just plastic. Depending upon what the situation is, plastic can be penetrated and break. Lexan is probably a better choice. And usually preferable to all types because of its relative simplicity and performance. Metal guards. Interlock guards. Anybody know an example of an interlock guard? Anybody in here? Injection mold plastic? You got interlocks on all those sliding doors. That door is opened up, you know, it kicks the hydraulics out. If the hydraulics are kicked out, that machine will not cycle. You know, so therefore, you know, you have to make sure, you know, that those doors are closed. You know, there are situations that I've seen happen, you know, whereas, you know, somebody in maintenance is setting up a machine, right? You're setting up a machine, and so therefore, you know, you have to have hydraulics in order to cycle it to get things set up. And in order to do so, you know, you have to have that interlock door closed. Well, if you have the door closed, and you know, then I can't get in there to adjust anything. So what people will do, you know, they'll actually take a piece of duct tape, piece of wire, whatever, and they'll actually close that interlock switch. With the door open, hydraulics are running. I can guarantee if somebody gets in that press, you know, to make adjustments, to do a setup or whatever, they better be careful. They better know what they're doing, and you better have a second person standing right there, you know, when it happens. Because I tell you what, those presses get real ugly real quick. So you get the interlocks guard the most dangerous part of the machine, prevents the operation of the machine. Should never prevent inching by remote control, which some machines out there can do that. Self-adjusting guards. The openings of these bearings are determined by the movement of the stock. Probably a good example of this is in your drill presses, or your small mills and things like that. There's actually devices out there that clamp around, you know, the chuck of the drill press that are collapsible. And so what you do, you have a drill bit in there. The drill bit's only hanging out like this on the bottom, but as you move this drill press down to drill your material, this guard actually collapses within itself, and therefore, you know, the mill or the bit is never really exposed to you to get your shirt sleeve caught in it. I'll tell you what, I've seen examples of shirt sleeves getting caught in drill presses. It's not pretty. These kind of guards can be made of, I've seen them being made out of sheet metal. I've seen them made out of Lexan. Like I say, there's a number of companies out there that you can buy these from. And if you've got someone who is within your shop that's pretty mechanically inclined, they can come up with a collapsible guard. Placing guards at a safe distance. This is usually a problem when designing guards for power transmission equipment. This is actually a table, you know, that shows, you know, that the distance from the opening to the maximum width of opening in inches. This formula right here is actually, you can find out on OSHA.gov under machine guarding. That's actually where that table came from. So if you're going to design a guard, you know, for a piece of equipment that you have, or you're looking to buy a guard for a machine that you may have, you know, make sure that it falls, you know, within these limits. Placing guards at a safe distance. Whoop. This diagram shows accepted safe openings between the bottom edge of a guard and various distances. There again, this diagram is available, on OSHA.gov. The minimum guarding line is the distance between the in-feed side of the guard and the nearest point of operation. This is the nearest point of operations. Therefore, where are you going to place your guard at? You don't want to place your guard right here next to it. You want to make sure that there's a distance in there. Devices control access to a point of operation that if they're tampered with or if they're not adjusted properly, they'll stop the machine if a hand or a body part is inadvertently placed. Restrain or withdraw the operator's hands. Require the operator to use both hands. We talked about that one, didn't we? 2 palm buttons. They've gotten these switches have gotten to the point anymore that they're very, very sensitive. That both buttons need to be pushed continually. I think there's don't quote me on this. I'm sure there's people in here who know more about this than I do, but it's in thousandths of a second. That you can't just put one down, lock it open with a toothpick anymore. That both of them have to be hit within thousandths of a second of each other for them to actually operate. Provide a barrier which is synchronized with the operating cycle. Allow safe lube. Be secure and tamper resistant. Machine guarding devices are presence sensing devices, 2-hand controls, pullback restraints. Anybody ever heard of a pullback restraint? Anybody ever seen those? They're still in operation. I know a company over up in Cleveland off of East 55th is still using pullbacks. That was a way that was put into effect many years ago to keep people's fingers from being cut off or stamped with a piece of stamping equipment. Presence sensing devices. These devices either stop the machine or will not start a cycle if the hand or any body part is inadvertently placed. There are 4 types of presence sensing. Probably the most prevalent is a photocell, light curtains. The machine's in there, it's cycling. If you put your fingers in there, it's not gonna cycle. It's automatic. It stops everything in the equipment. So the light curtain must be positioned at a minimum safe distance. You want it to be effective, but there again, you don't want it to slow production. Radio frequency presence uses a radio beam that is part of the machine control circuit. When the capacitance field is broken, the machine will stop and not activate. Like a light curtain, this device shall only be used on machines which can be stopped before the worker can reach a dangerous area. That's the purpose of any guard. Make sure that it's effective enough that if it's a pressure-sensitive device, whether it's a light curtain, whether it's a adjustable guard, a permanent guard, make sure that that's effective before somebody gets hurt. There's no use having a guard out there that people can still get injured. And there are companies out there that will say, well, it had a guard on there. Well, that's nice to have a guard. If it had an opening like this, Electromechanical sensors have a probe or contact bar which descends into a predetermined distance when the operator initiates the machine. An electromechanical sensing device is shown on this riveter. There again, it's the same thing. These there are some guards out there that actually I picked one up. It was on the internet. It's been maybe a year ago. It was a table saw. Anybody ever seen that one? The table saw with a hot dog. That's pretty interesting. You have a table saw. It's set there. It's cutting wood. It's cutting plastic. It's cutting anything. You take a hot dog, and as soon as it touches the blade, that machine just locks up instantly. It's the same thing if your finger would get in there. You just lock up instantly. And why more manufacturers have not adopted that, I really don't know. There's a lot of people in the woodworking industry that I've been doing this job for the last 50 years. Nobody's going to tell me, to put a kickback bar and a guard on my table saw. I've been running this same saw for years. I know what to do. I know where not to put my hands. These are the people that have 3 fingers on one hand and 3 on the other, because they've been at it so long. I know how to do that. Pullback restraints. There again, that gentleman over here said he's heard of pullback restraints. What that allows you to do, especially in a punch press type operation, what that does is that When the machine cycles, you've got wristbands on, and usually a set of cables that goes this way through a set of pulleys back over here to the machine. Sounds chaotic, doesn't it? And what happens when you push the buttons for that machine to cycle, that when the machine comes down, it pulls your arms back. And so this is what you're doing all day long. You know, it's chaotic, it's archaic, it's unbelievable, you know, the strain it actually puts on people. But there again, you know, they are still in use, and they are effective if they're adjusted properly. There again, you have to be adjusted properly. I mean, if your arms are this long, then that's what they have to be adjusted to keep your hands from that being that punch press. If your arms are this long, well then, you know, you need to have another adjustment. So therefore, these things need to be adjusted all the time. They have a lot of wear not only on the machine, but also a lot of wear on the operator. But they work. They do work. Pressure sensitive bar, when depressed, it will deactivate the machine. There again, safety tripwires, things like that. That was probably the precursor to the light curtains. The gate is a movable barrier which protects the operator from the point of operation. You know, what a lot of companies will do, they'll use this kind of a guarding device in conjunction with other devices. You know, people say, well, what do you mean I have to have two kinds of safety guards on this machine? Maybe. Yeah, maybe. There again, the two-handed controls. Like I said, they've gotten very sophisticated with these anymore. You know, like I say, it used to be you could beat the system. You know, you can't beat the system no more. You know, but people tried it. There again, you know that if you're working in a situation, you know that you're on a piece rate, you want to make as much money as you can. If it takes a way to figure some of this stuff out so I can make more money, then that's probably what you're going to do. Now, when the boss comes around, you know, you're going to say, you know, you'll be okay. Do it the way you're supposed to do it, but as soon as he or she walks away, bang, you're making money. When guards or devices cannot be used, other methods can be selected. You know, therefore, you know, a safe distance. You know, stay away from it. You know, there again, you know, you shouldn't have to tell people, you know, not to stick their hand in the fan. But I'll tell you what, sometimes you do. Because even though that guard, you know, is on that fan, and for whatever reason, you know, it gets a bunch of debris clogged up on it or this or that, what are you going to do? It's 105 degrees in the shop. What are you going to do? Yeah, take the guard off of it, man. Paper and debris and things keep catching on that guard, and I'm not getting any cool air off of it. I'll remove it. I'll just move it out of the way. I'll adjust it. Do whatever I have to do. Safe holding, this method is used that is designed and constructed so that when the operator is required to hold or support a piece of work, the operator is prevented from inadvertently reaching into the hazard area. Shears, you know, a lot of metal shears, you know, use that. There again, a lot of veneer companies, a lot of paper industries, cutting big books of paper. Safe openings, the opening when no work piece is small enough to prevent any part of the operator's body from entering the area. You know, it's nice that we have a guard there, yeah, but still I can put my hand under that, you know. Or if I have a light curtain, I got the light curtain adjusted up here, my table's down here, guess what? I can reach in there, push more material in. Safe position of controls. The controls require continuous activation to complete a hazardous portion of the cycle. You know, it used to be that a lot of these older machines that were out there, especially punch presses, things like that, forming presses, that once you activated the cycle, it would continue. It'd make one cycle before it would stop. They soon realized that was probably not a really good idea. You want that machine guard set up, you know, to the point that if indeed any time during the cycle, whether it's at the beginning of the cycle, a third of the way through the cycle, halfway through the cycle, whatever, that if that guard, that light curtain, that pressure sensing device or whatever it may be is activated, machine stops. Like I said, the older mechanical type, it would continue to cycle, even though your hand was in it. Safe distances, that's probably the best thing. Just stay away. Unless you have a real need to be there, or to operate this piece of equipment, just don't be there. Managing the safeguarding program is more to machine guarding than just guarding machines. The employer must ensure that the employees are trained to do the job, ensure that the employee wears personal protection equipment, establish safe operating procedures, and supervise to ensure compliance with the company's rules. There again, you remove a guard, you adjust a guard, you do anything with the guard that you're not authorized to do, it's disciplinary action. That way we make sure that we keep our employees safe. The other thing is, that we want to make sure that the employees are properly trained. Where these pinch points are, where these reciprocating shafts are, conveyors, where the hazards are. I think too many times, that we get caught up in the fact that we're busy. We hired 3 people yesterday. We're going to hire 2 more people tomorrow. And I'm the HR person, or I'm the safety guy, or whatever. And I really don't have time today. I got more interviews to do. I have to do this. I have a report to do. And so what are we going to do? You hired the 3 people today. You're going to say, okay, well, I'm kind of busy right now. Why don't you go over here and work with John for a while? He'll show you what to do. Well, John started working yesterday. He doesn't know any more about it than you do. So now instead of having 1 person in a compromising situation, now you have 2. Because John didn't know where the pinch points are at or where the hazards were on this piece of equipment. The only thing John was told to do, you go over here, and push this button and somebody will show you what to do. I'll be out tomorrow or later this afternoon and show you the proper way. But right now, I'm busy. Next thing you know, somebody gets hurt. Next thing you know, you're out there. You're out there doing your job that you've been at now for 2 hours, and you're running this piece of equipment, and you get a jam. You get a jam, you get a problem with the production cycle or whatever. What are you going to do? Well, there's nobody around. I want to make sure that I make a good impression on people by getting my production done, or getting this job done, or getting that job done. I'll take this guard off, and I'll reach in there. That wheel's only moving like this. It's not very fast. I can get in there and snatch that out of there before that cycle comes around again. And it doesn't happen. Next thing you know, somebody's seriously injured. Like I say, any kind of training that you do, make sure that it's documented. I want to make sure that I spent, 2 hours with this person, 1 hour with this person, or Bob worked with this person, or whatever, and make sure that they sign off that they will understand, what the hazards are, what not to do, and what to do. Managing a safeguarding program, even the most elaborate safeguarding system cannot offer effective protection unless the worker knows how to use it and why. It's probably the most important thing. Why is it here? Well, because John said it was going to be here, I guess. I don't know. Nobody told me other than the fact that it's here. I was told not to do anything with it. Just do my job, and if this needs to be adjusted or that needs to be adjusted, you call maintenance. That's generally what needs to be done. Don't take it upon yourself. If you've not been properly trained on all the hazards of the machine, or how to unload a jam or whatever that you may end up with, somebody's going to get hurt. And like I say, when you start removing guards, most of these injuries are not scratches. Safeguarding, what the operator's responsibilities are, the parts and function of a machine. Like I said, some of these injection mold plastics presses are, pretty sophisticated. They got a lot of safeguards built into them, but you take an operator who's been out there for a number of years, they know how to get away with a lot of them. Any questions, thoughts, ideas?